Hi, welcome to lesson 23a, Discrete Random Variables. The goal of today's lesson is to learn what discrete random variables are and how they can be used. So, over the past couple chapters we've been talking about experiments, and I guess we have been investigating a little bit while we've been doing experiments, and we've been talking about, we've been setting we've been looking for a probability of number of red tickets, blah blah blah, taken out of a hat, or the probability of the number of blue marbles, etc. So we've been doing stuff like that. So what we want to do now, though, instead of setting that up, like writing out all these words and whatnot, what we're thinking about doing now is we're going to take the idea and just set some variable to it. So we can say, let's investigate if we have a number of red tickets. Let's again, my little bag that I can't draw very well. So we have this bag full of red and green tickets. Inside you cannot see, of course, from the outside. And we say, okay, well, let's find the probability of drawing a red ticket on the second or third draw, or something like that. So instead of saying, writing all this out, we'll just say, let X be the number of red tickets drawn, and so then what we can do is just say, well, then the probability of X equals 1 is such and such, depending on what the number of tickets altogether, and then the probability of X equals 2, the probability of X equals 3, etc., etc. So then we get an idea. We can just quickly write that, because what we know is we're already letting this variable X, and this is an uppercase or a capital X for each of these. We already know that X represents the number of red tickets drawn out of the bag. So then we want to find the probability when X equals 1, or the probability when X equals 2, etc. Okay, so now in this case we're talking about the number of red tickets. So in this case we're talking about a discrete random variable, and the random comes from the experiment that we do where we are randomly drawing tickets out of a bag, or randomly drawing number of marbles out of a bag, kind of thing. It's all random stuff, so that's why the probability is what we're looking for to predict future draws. Because if we knew what we were drawing out, then it wouldn't be random and we wouldn't have to predict anything, because we would know exactly what's being drawn out of the bag. So discrete random variable is when the variable can only take on integer values, positive integer values. So if we're talking about, say, the number of houses in a neighborhood that gets struck by lightning, well, the number of means it's going to be a random variable, discrete. It's either going to be a house that gets struck or not. It's not going to be like 1.5 houses, for example. The number of geckos sold at a gecko shop. The number of defective popsicle sticks in a box of popsicles. So those are all discrete, because it's the number of. You can't have fractions of these values. Next we move on to continuous random variables, and it's the same sort of idea. So continuous random variables, it's the same, except that the variables can be used in ranges. So these variables that we're going to be choosing are a result of being measured. So if we talk about heights of trees over time, or the volume of soda that's in a kitchen sink or something like that. These are measured values, and they can take on any value in some sort of range. So when we talk about discrete random variables, we'll be saying, okay, well, if the probability of x greater than some value is such and such, or the probability of x being less than or equal to some value. So that's where we get more of a range involved. Now we can still do the ranges with the discrete, but the values that we get, that we are using, will all be integer values. Whereas values with the continuous random variables, those are going to be the ranges of values for sure. And along with values that are inequalities, come words along with them that are useful to us. So we can say at most. So if we're talking about at most, that means that it's going to be less than or equal to. Okay, so it's at most some value, so that means it's going to be that value or less. Okay, it can be in that range, so that's where we use less than or equal to. If we said at least some value, then we'd say that it's greater than or equal to. Equal to because it's that value, and at least that's the smallest value, and therefore it can be greater than that value. Okay, so there's a lot of wording that goes along with these inequalities. And there is a table in the textbook, I forget exactly where it is at the moment, but there is a table in the textbook that gives you the values of, or the description of those inequalities and what words would be associated with them. Let's see if I can quickly find this here for you. And I think it's actually, okay, so this is actually in section 23b. Okay, so I'll go over that in a little bit more detail in the 23b video. Okay, so suppose we say, for example, we want to find, or we're interested in the number of heads of the flip of a coin. Okay, or we're tossing two coins. So if we're tossing two coins, then obviously we know that x is the number of heads, and x could equal 0, could equal 1, or it could equal 2. Okay, so if we're flipping heads, or sorry, coins, two coins, the variable could either be 0, 1, or 2, and so then the probability of x equal to 0, well, if there's 0 heads, then that means there are 2 tails. So that's going to be 1 out of, well, there's going to be a possible 4 outcomes. So there's tail and tail, here's head and tail, and then there's tail and head. That deals with the 1 head, and then there's head and head for the 2 heads. So the probability that x equals 0, where there's 0 heads, is going to be 1 out of 1, 2, 3, 4, so 1 out of 4. The probability that x equals 1, so 1 head, well, we've got 2 possibilities there, so it's going to be 2 out of 4, which then simplifies to 1/2. And then the probability that x equals 2 is going to be, well, here's the only possibility here out of the 4 outcomes, so it's going to be 1 out of 4. Okay, and so when you're tossing 2 heads, you're going to get one of these 4 outcomes. So with certainty, at least one of these scenarios will happen. Therefore, when we add all these different probabilities together, we're going to equal 1. Because on any flip of 2 coins, it is with definite certainty that one of these 4 outcomes will occur. Therefore, the sum of all those probabilities has to equal 1. Okay, so that's basically the long and the short of discrete random variables. What I'd like you to do is take a look at example 1 from page 609 and let the self-tutor talk you through the solution of that. And then look at page 609 and 610, a quick glance of the examples, or so the exercises 1 to 4, which you'll have time to work on in class tomorrow after we look at the examples in class. So, thank you for watching, and we'll see you in class.